Okay, pre-calc, chapter 6, additional topics in trigonometry, and we're going to start with the law of sines, which I think most of you have seen before. We're going to take this a step further and introduce what we call the ambiguous case today. But we're going to use the law of sines and pay attention to the fact that this is the one time we use trig functions to find angles and sides when we don't have right triangles. We're going to then introduce the ambiguous case. Tomorrow we'll look at formula for the area of a triangle, and we are going to apply these also. We've got some great problems with bearing problems, which I know you guys love. So let's jump into it right off the bat. The law of sines, an oblique triangle is a triangle that does not contain a right angle, as in the figure shown. The oblique triangle has either three acute angles or two acute angles and one obtuse angle. Notice that the angles are labeled A, B, and C. The side opposite each angle are labeled as lowercase a, b, and c. Now, you guys, we're going to refer to an angle. If I talk about angle A, then I know that both B and C are going to be adjacent to it. It'll be this one that we're talking about as being adjacent because this one we're not going to define. If we're looking at angle A, then side A is always opposite that angle. So when we're looking at this stuff, don't get too confused. All right, the law of sines is simply stated. A over sine A equals B over sine B equals C over sine C. And I like to take the reciprocal of those. For some reason, I use that more often than I do what they gave us. It just feels better to me. It doesn't really matter, you guys. It's whatever you like best. All right. And I should go into some explanation, you guys. Just for the length of the video, I'm not going to. What happens is we have some right triangle, and we are looking to figure out more information about them. If we go ahead and draw in an altitude, we can then create a right triangle or two right triangles, and we call this H. And what we end up doing is we set everything to H and then substitute, and we end up with this. And I'm not going to go through it all, obviously, for time's sake. I'd love to, though. All right, so we're going to solve the triangle shown in the figure, which I didn't give you, and I didn't give it to you on purpose, you guys, because we need to be able to draw a triangle. So it's a 64-degree angle. So do the best you can. That's 64 degrees. That's A. Angle C is usually going to be up top, but it really doesn't matter. So just draw yourself a triangle. It can be an equilateral triangle. This is going to be 82. Therefore, 180 minus those two angles is 34. This was C, this is now B. We know that side C is 14. Okay, now don't know if you actually need the picture, but now from there, we go ahead and start going sine of 64 over A, right, because that's A, equals sine of 34 over 14 equals sine of 82 over B, where this is side B. And now you've got a couple things going on. First of all, here's a proportion you could solve, and at the same time, here's another proportion you can solve. When they say solve the triangle, they intend for you to find measure of angle B, which we already have done, 34, side A, and side B. So we're going to go to work and cross multiply and solve and see what we can come up with. I'm going to pause the video and actually do the work, so I'm going to suggest you do the same thing. And I'm going to start with the red box, and we are going to cross multiply. Okay, and the directions didn't tell you, but we should round angles to the nearest whole usually, and sides to the nearest tenth. Directions should tell you that, so this is going to be 22.5, whatever the inches are. And then we've got to go back and work and find B, right? So I'm going to put 22.5 here. I'm almost done. And you can check my work. I'm going to pause it again and let you guys work through it also. And B equals 24.8. And we have solved the triangle. Finding all the missing pieces solves this. All right, so I'm going to go ahead and just fill this in the law of sines. We're going to start out and just say sine, whoops, got to have a pen, sine of 40 over A equals sine of B over 12 equals sine of C over C. Now, the key here is notice that you have to have a completed ratio. You've got to have both numerator and denominator completed in order to do any work. So in this case, you're going to, and sorry about that, but I didn't fill in. C should have been 22.5. So I need to either find B, C, or A. Well, since I've got two angles, I know I can find B. Once I find B, then I can go ahead and start cross multiplying. So clearly 180 subtract 40, subtract 22.5 gives me 117.5, and now I've got my completed ratio. I can use those two for one proportion, and I can use these two as the other proportion. I'm not going to continue with this one. I think you got the idea. This is where we want to spend the remainder of our time. I'm going to go ahead and list the things that you need to memorize. If you don't memorize these, then we're going to be in trouble. But keep in mind that when you are dealing with a angle side scenario, in other words, you're given some angle, a side, and the opposite side here, this angle right here is not fixed. This side here is not fixed. So we don't know where that is. That could be anywhere here. And the question is, where does it meet the sides? So in some cases, it's going to meet right here, and you're going to have one solution. That's going to be a right angle. In other cases, you've got a side that's too long, or is going to be long, and you're going to only have one solution. Or as I drew in here, this could either be here or here, which means that we could possibly have two different triangles to solve here. Okay? Those two triangles, and I'm going to draw them out real quick, are simply, you're going to have a triangle that's like this, or you're going to have a triangle that's like this. And notice that in those triangles, that the angle side that's given haven't changed. They are still the same, so you really have two solutions that you're going to have to find. Okay? So I'm going to pause and write down the list. you guys will probably pause and have to write them down. Okay, again, I would suggest that you pause the screen and write this down. You are going to need to memorize this, otherwise you will not get these questions correct. Or at least have them written down. I guess since we're doing this at home, you'll have access to notes. So let me go through it real quick. If you have an obtuse angle, then you have two options, either the side opposite. Here's an obtuse angle. The side opposite is too short and you have no solution, or it's longer than the side adjacent and you have one solution. Then you have this scenario where you have an acute angle like they have up here. We gave you the acute angles, and there's 4 scenarios here. If you have an acute angle and the side opposite is bigger than the side adjacent, then you're going to have one solution like they do here. And then we go down the last 3 here. If you have an acute angle and the side opposite is less than the side adjacent, then you have to find H. Okay, if you don't find H here, you're going to not be able to solve these problems. Then it says, and I made the mistake here, I'm going to make the change real quick. All right, so I put adjacent instead of height. So the next 3 steps say if the side opposite is less than the height, then there's no solution. In other words, this opposite side won't reach that, and you can't have a triangle. Or if it's equal to it, then you're going to have one solution. That means you're going to have a right triangle there. And then lastly, the scenario we had talked about before, that if the opposite is greater than H, then you might actually have 2 solutions like the green and red triangles that we had created here before. All right, so let's work a problem. Okay, I only have about 3 minutes before I run out of time on this video, so I'm going to stop and do some work and let you guys analyze things. But to start with, we've got a triangle. So notice that we have an acute angle, and the side opposite here of that acute angle is bigger than the side adjacent. That means we're going to have one solution, and you're going to solve this the same way we have the previous problems. You're going to go ahead and solve the first proportion and find B. Once you find the inverse function, remember this is going to require inverse sign to be able to find B, right? Once you find B, then you'll be able to find C. Once you find angle C, then you'll be able to find side C, and you're in good shape.